Hi guys, this is Mrs. Gastler, and in this video we're going to talk about calculating acceleration from a v versus t graph. I think the lesson is called slope again, because maybe you didn't think we were going to ever do slope again, but we totally are, and that's okay. So we're going to be doing slope in this one, which means it's going to be somewhat familiar. Isn't that wonderful? Okay, so we have here an example that is very similar to the practice that you're going to do, and also similar to the practice that we did in constant velocity. So we've got Todd and Maeve. They're marking the position of a traveling toy car, and then they find the average speed between each dot by dividing the distance by the time between the dots. And this is the data that they have. So we're going to draw a graph, and it says that we need to put velocity on the y-axis and time on the x-axis, and then we need to figure out a good scale. Oh, and this is going to be a velocity versus time graph. That's our title. Okay, so I go from 0 to 7. I think I'll go up by ones here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I won't go all the way to the edge, but that's okay. And then I've got from 1 to 18.5. Looks like a square. I think I'm going to go up by 2. So 0, 2, 4, 6, 8, 10. That's an 8. 12, 14, 16, 18, 20. And that'll allow me to get all those points on there. And so now all I have to do is put the points on it. So let's see, 1 at 0, which would be halfway in between there. 1 and 3.5 would be a little bit closer to 4. 2 and 6. 3 and 8.5 would be a little bit above the 8. 4 and 11 is right in the middle. 5 and, let's see, 13.5 would be closer to the 14. 6 and 16, and 7 and 18.5 would be just above the 18 there, okay? And then it says to draw a best fit line, and so I'm going to do that with this pencil here, and this is a Post-it, which you might have seen before. Okay, so that looks pretty good. I'll just draw that right there. There's my best fit line, okay? It's okay if your dots don't all end up on your best fit line because it's a best fit line. They don't have to all be on there. Let's see, it says, what is the velocity of the car at 3 seconds? So we can either read that from the graph or we can read it from the data table. At 3 seconds, it is going 8.5 centimeters per second. And at 5 seconds, it's going 13.5 centimeters per second. And so that's all it's asking me to do. How much did the velocity change during that time from 3 to 5 seconds? Well, it went from 8.5 to 13.5. And I always do the final first, right? So the V final minus V initial will give me the change. So 13.5 minus 8.5. Oh, goodness, I don't have a clue what that is. Let's see. 13 minus 8 is 5, and the 0.5s don't matter. So it's 5 centimeters per second, okay? Is the answer to part C the same as the acceleration? Ooh, that's a good question. Is it? Well, this tells me how much it changed in a, let's see, 3 to 5 seconds is a 2-second period, and acceleration is the rate, so it's kind of the acceleration, but not. So I'm going to go with no, because it's just the change in velocity, not the rate. Okay, so it has to be a rate to be an acceleration. So when we calculate the slope of the line, I'm going to go ahead and use those points right there. So at 3 seconds, it is 8.5, and at 5 seconds, it is 13.5, and my slope is the rise over the run. My rise is how far I go up. That was the thing that I calculated here. So that's the 5 centimeters per second. And the run is how far I went this way, and that's from the 3 to the 5. So that is 2 seconds. So that gives me, let's see, half of 5 is 2.5 centimeters per second squared. Now that's a weird one, and if you wanted to write centimeters per second, that would be totally okay, especially if that makes more sense in your brain. So just to clarify, I use these points to get the rise and the run. What does the slope of the line represent? Okay, so this is where we can write down that it is the acceleration. The slope is the acceleration. How do I know? Because it is a rate of change in the velocity. So what I did was I took the change in velocity and I divided it by time, okay? So per time is how I know I have a rate. Per time, this part right here means I have a rate. And change in velocity, the rate of change in velocity is acceleration. We defined that on another lesson. So that's a great place to start here, okay? If that went a little too fast for you and you're not sure what to do next, make sure you ask your teacher for help. We do have a couple more where we're gonna practice finding the slope again. Hopefully you're becoming rock stars at finding the slope of a line. Remember that the first thing we have to do is we have to find points. If it goes through 0, 0, I really like that one because that makes my numbers easy. And as long as you pick a dot that you can easily see what the value is, you're gonna get a better answer. So my rise is from 0 to 20 centimeters per second, and my run goes from 0 to 8 seconds. So I'm going to do 20 centimeters and 8 seconds. And I've got a handy calculator here. Oh, it does work. Wonderful. 20 divided by 8. Remember, we don't leave things as a fraction. We have to type this into the calculator. Type into calculator, okay, because we need to know what the answer is. And I get 20 divided by 8 is 2.5. Okay, now I can write centimeters per second, or if you wanted to write centimeters per second squared, that's okay too. Either one of those, both of those are correct ways to write it, so you can choose the one that works better for you, okay? Now I have another one here. This one says velocity versus time. And we've got meters per second now. So let's see. Ooh, this one's on the bottom, like it was in our notes here. So what does it mean down here? That means it has a negative velocity. Okay, so I'm gonna have to be careful. Let's see, this dot and this dot. Those are pretty easy to see. You know, I should draw my little triangle up here. So there's my rise, and there's my run. Okay. Remember, don't count boxes when you find the rise and the run. You have to use the scale, okay? So my rise is right here. It goes from -8 to, oh wait, it doesn't go from -8. It ends up at -8. It goes from -4 to -8, which means I'm going down -4, okay? And then I gotta stick a unit on there, meters per second. And my run looks like I'm going from 4 to 7, okay, 4 to 7, that's what, 3 seconds. So my slope will be -4 meters per second divided by 3 seconds. Let's see, 4/3, I think I know that one. 4/3 is 1.3, and we don't need to write all those. We also don't put the bar on top because the bar is too specific. It's okay. And then my unit will be those, and just like I did in the last one, meters per second would be okay, or centimeters per second, whoops, not centimeters, meters per second squared. So there is my answer, okay? Last one, this one, ooh, this one starts going in the negative direction. It stops right there, and then it continues going in the positive direction. So let's see. So my slope will be positive, and this slope was negative. So let's see, I'm just gonna pick that dot because I already got my pencil line on there. And some of these are harder to read. Let's go with this one, that one's pretty good. Okay, so here's my run and there's my rise. And so my rise, I go from -30 to 0. -30 to 0 means I'm going up 30, so that's positive 30. And this one, ooh, this one has miles per hour. This one's going to be a fun unit. And my run, I go from 0 to 10, which is 10 seconds, okay? So 30 miles per hour and 10 seconds on the bottom. Oh, I can divide 30 by 10 in my head. That's 3. And this unit, I can only write miles per hour per second because the hours and the seconds don't really match, so I can't put a squared on it like I did on the other one. So that is the only thing I can do, okay? So the acceleration is the slope of this line, which means if the slope of the line is steeper, that it's accelerating more. It's got a higher acceleration. To give you some context, if we were having a drag race, the car that has the bigger acceleration is going to be getting out of that starting lane faster, okay? All right, that's slope. There's some more practice for you on the back side and also the next page. If you need any help, please make sure you ask your teacher. Thanks for watching.